We are making unicorn noodles. I have my boiled cabbage noodles that were cooked in cabbage water, which was a combination of boiling cabbage with water. Okay, we've used red cabbage. And the final part of our ingredients after we have our beautifully blue noodles is to add our beautiful second ingredient, which is lemon. And you can use fresh lemon, or you may use lemon juice. If you want to spice it up and make a different variation of the noodles, you can even use lime juice if you're interested in. Depends on the flavor you're going for. So I've squeezed my lemon and I have my lemon juice ready. I've poured out some cabbage water so that we can test it. And we're forming our hypothesis now. Who would like to share their hypothesis in the if, then, because format? If I add lemon to my beautifully blue red cabbage noodles, then you tell me what you think is going to happen. Because, and we're accessing our schema to figure out from our experience what we think will happen with this combination. So I want to hear your thought process. If you just said it's going to come alive and walk off the table, I don't know that we have enough evidence to support that. All right, who would like to share their hypothesis? Who would like to share their hypothesis? All right, Jaden. Okay, so you think flavor-wise, the lemon's gonna overpower the cabbage flavor? All right, fair assessment. Okay, what do we think, Valentino?
If I squeeze a lemon on the cabbage noodles, I think that it will have a little taste of lemon. Because once I put lemon juice on in my soup, and it had a little hint of lemon.
Okay, so it's gonna taste like lemon. So we're basing, because we knew this was special ingredients. We knew we were cooking here. We're on the Miss Velez cooking show here, or the Jupiter Velez, my unicorn name. So we think flavor-wise, the lemon's gonna be overpowering. Anyone else think anything else is gonna change besides the flavor or the taste? Lenny? Ooh, so Lenny thinks that there's going to be a chemical reaction resulting in a color change because the lemon is a citrus fruit, and she thinks when it combines with the cabbage, there's going to be some sort of chemical change. Anyone else think the same thing as Lenny? Okay, anyone else think something else is going to happen? Mateo?
If I put lemon juice on it, then it will take all the color out. Like, it will bleach it.
Bleach it. And what's your reasoning behind that?
Because of the chemicals in the lemon juice. Because then you have bleach on the table.
Okay. He's using some of my other clues with the bleach, guys. All right. Any Zoomies have a hypothesis they'd like to share? Any Zoomies? Seraphin or William, anyone? Okay, so why don't we get down to it? You can't change your hypothesis afterwards. So for the purpose of this experiment, I'm going to start off with a test tube so that you can clearly see. Can you guys see up there if I keep the lights on? Let's see. All right. Here's my beautiful test tube ready to go. Okay. And I'm going to take my lemon juice. Are we ready? Going to take my lemon juice. I have my test tube filled with. Here we go. We've got our bluish purple cabbage water. I'm going to pour my pretty clear lemon juice into it. Ready? Yeah. Not everybody's looking. I'm covering. What happened? What happened? Ta-da! I have a magic potion. This was what I started with. This is what I ended with. So, fifth graders, eyes up. Eyes up. All right, fifth graders, including my Zoomies. Was your hypothesis correct? All right, I have some mixed reviews here. So, I'll wait, gentlemen, ladies. Did so what kind of change? We obviously have a change that happened here. What kind of change did we have? A physical change or a chemical change? Jaden, physical or chemical? Think about it. Chemical, who can give me a reason why this is a chemical change? Why is this a chemical change? Chris.
Because we went over this, like in the like before, like what is the chemical change? That when substance changes color, that would become.
Yes, when we have a color change, it's usually an indicator that we have a chemical change. That being said, now I still have my beautiful, gorgeously blue unicorn. We'll have to nickname this, I don't know, space noodles. Like we've got alien guts, however you want to call it. When you serve it to your family, I don't know, these are beautiful to me.
Does it taste better though?
They taste like cabbage. You gotta add your own spice.
When you add the lemon, does it taste better?
Oh, lemon always makes everything taste good. So now I need a volunteer to do the honors of spritzing a little lemon on my pasta. And this is what you do, by the way. You don't do this until you serve. When you serve this to your guests, right? Whoa. When you serve it to your guests, it's kind of like, you know, when the server comes around with the Parmesan? You would come around with a beautiful little bottle of lemon juice. And you would say, may I? And reach over and give them a little spritz. So I need someone to help serve. Who brought a lemon today that would like to use their lemon so I can preserve some for... Is yours cut? I see Danielle has a cut lemon. Danielle, do you want to come? I need someone. You can hold on. All right, Miss Danielle, we'll do the honors. I'm at my fancy restaurant. Hold on. So, for the purposes. Sure. All right, wait, hold on. So I'm gonna turn the lights off. So hold on. I'm gonna shut the lights off so you can see it on camera. Please take a seat. I'm going to illuminate it. I'm going to illuminate it with my flashlight. Can everybody see the blue now? This is my special reveal. Okay, hold on. Let me make sure that. Let's see. This way will be the best. I feel like we're definitely getting the food Instagram ready. All right. All right, fifth graders, are we ready? Fifth graders, ready? Ready? Set, go. It's okay. Keep doing it. Keep doing it.
Yes, please. More.
We might need more light for this.
Give it
All right, Danielle started us off. Can I have another lemon? Yes,
I have the passion of it.
Kayla.
I have the passion of it.
All right, ready? Go on the other side.
Don't be shy, put some more.
Just like the Parmesan, keep it coming, keep it coming.
Don't be shy, put some more.
Look, all right, we gotta move your hands so they can see it. Fifth graders, what are you seeing?
Purple alien race. Don't be shy, put some more.
What are we seeing, fifth graders?
Don't be shy, put some more. Purple alien race.
All right, ready? Release the lemon. Fifth graders, what happened? Thank you to our fabulous. Thank you to our fabulous Danielle and Kayla for making our unicorn noodles. What happened to the noodles? What do we notice? All right, let's have some volunteers. What happened to our noodles? So here is our final product. Okay. Beautiful. I'll come around so everyone can see. And I'm going to need some volunteers to let me know. We definitely know that we saw a chemical change because we had a very strong indicator. Our strong indicator was a change in color. The reasoning behind that, I think Lenny got pretty close with it. It has to do with the chemicals of the lemon and the chemicals of the cabbage. Okay? It is so before we get into the chemicals of either of those, I want to introduce you to two more terms, and that is acid and base. Have you heard of any of these? Okay. So when we think of these two terms, these are basically opposite words. We probably more commonly know an acid, right? Well, acids have a low pH and bases have a high pH. For reference, water, which is considered neutral, has a pH of 7 on a scale of 0 to 14. If we have a low pH for acids, something that has a strong acidity, like lemon, would be closer to that scale of 0, right? Lower pH, lower number, right? And bases have a high pH. That's something that is the opposite of something that's considered acidic. Yes. It's level of acidity. How strong, right? The level of acidity. Okay? I'm going to wait. So pH itself stands for potential of hydrogen. So we're looking for potential of hydrogen. It represents the ratio of hydronium ions, which is H3O. That you guys know what you could probably figure out the molecular right structure of H3O to hydrogen ions, which are OH. Remembering your elements here. Okay, So it's a measure of acidity, basically. Obviously, our lemon or any citrus fruit, you can use lime, you can use an orange if you want to get crafty. Okay, any citrus fruit has a strong acidity. So we're going to be lower on that pH level. Yes? All right. So scientists can tell if a substance is an acid or a base by using an indicator. An indicator is typically a chemical that changes color if it comes in contact with an acid or a base. A natural indicator would be cabbage water. It is considered a natural indicator because it very easily changes color when there's a presence of an acid or a base. Excuse me. You may have seen pH strips elsewhere. Who has seen pH strips? I'm looking for those people that have either pets or pools. Who has a pet that needed pH strips? What kind of pet am I talking about? Not your dog. What kind of pet? Yes. Yeah, an aquatic animal like a turtle or a fish. If you ever had a fish tank, okay, or something with water, guess what? You were absolutely, I'll wait. You were absolutely probably testing the water for acidity levels, especially with the turtle. I hear that turtles are highly acidic, right? Their water, if it's not cleaned, can be extremely acidic. So it's something that requires a lot of maintaining versus, let's say, a goldfish that is not as acidic. Sebastian? So as you can see, the purple cabbage juice turns, because we have that beautiful indigo, bluish purple.
Hello, School of St. Catalan. This is Miss Walworth.
Here we go. So as you can see, the purple cabbage juice turns red or pink, right? When something acidic is mixed into it. And if I were to mix something that was on the opposite of the spectrum, something that was considered a base, more neutral, more basic, right? Less acidity, you would actually see a greener color.
Also, if you added like water to it.
Water is neutral. So water would be right in the center, right? It has a pH of 7. It will definitely, because
So what will it do then?
I'm going to show you a picture of it in just a minute, okay? So, well, think about it. If I took this and I poured water into it, what would happen? It would get lighter. It would get lighter.
Like if it's watered down,
Right.
it's like less of its original.
Right. Exactly. Okay?
Bye. Thank you. Bye, everybody.
All right. So, sorry. Okay. So, red cabbage juice is considered to be an indicator because it shows up something about the chemical composition of other substances. Yes, Mateo.
What happens if you put the lemon just on cabbage?
It'll do the same thing. It's the chemical. So the question that came in, Zoomies, was what happens if you put the lemon directly on the cabbage? The cabbage will turn a pinkish color as well. It's the chemical itself. Well, you can kind of see here where I had blue cabbage that was boiled. So we'll look at it in just a minute. So there's a chemical that's present in red cabbage, is why I said use red cabbage. That, right, is a very strong indicator when mixed with other substances that can either identify it as an acid or a base. Yes. You can wait. All right. What is it about cabbage that causes this to happen? So here's the pigment I was telling you about. Cabbage, red cabbage, contains a pigment called anthocyanin that changes color when it's mixed with an acid or a base. So the pigment will turn, as you saw here, right? Red in acidic environments, okay? With a pH that's less than 7. And the pigment turns bluish green in alkaline or basic environments with a pH greater than 7. So I'm going to take, and I might need to put the lights back on again here. I'm going to now take another chemical, and this one I don't want you to trying at home. I'm going to take some Clorox bleach. I want you to think about what we know about acids and bases. Think about it. And I want you to, and we'll just take hands this time, aloud, who would like to share a hypothesis of what they think when I mix the Clorox with my indicator, which is my red cabbage water. Anyone want to share what they think might happen? And I might have to shine my flashlight again. Sebastian? You think it'll take the color away? That's a fair hypothesis. Why do you think that might happen?
Because, like, I've used Clorox before, and it's like really acidic.
Yeah, you've used Clorox or bleach before, and it usually removes color. Anyone else have a different hypothesis? Or yes, Julian? Okay, Julian thinks it's going to become a bluish greenish color. Let's hear your reasoning. Oh, Julian says it's a very strong base. So it's going to be on the opposite spectrum of the pH level. Anyone else have another hypothesis? Jaden? Maybe some bubbles. Interesting. All right. Who can I trust to pour Clorox? I'm going to keep it away from my dinner. My dinner should not be compromised. We don't want the teacher eating bleach. Okay, thanks. All right. So I've got my Clorox. All right. I have my ingredients. See if I can get a closer view for my. And don't get it on your uniform. Ready, guys? What happened? What happened? Did we have another chemical change? Yes, who's still speaking, ladies and gentlemen? I'm just gonna balance it out a little. Watch what happens as I balance. When I say balance, what do I mean? I'm talking about the pH level. Watch. So fifth graders, what does that indicate about our bleach? Anybody want to try that I haven't heard from today? I have a lot of similar hands. Maybe one of my Zoomies. Zoomies, what does that indicate about my bleach? Seraphin?
That it'll turn the cabbage water into yellow.
Yeah, it turned it yellow. Do we think that indicates it's acidic or more basic? What do we think? Is that more acidic or more basic? What does the class say? Who thinks more acidic? Who thinks more basic? All right, so we don't have that bright red. We know that We know that our cabbage started off blue. Let's take a look at a little bit of a spectrum of how to indicate. It's kind of hard not knowing what your spectrum looks like. So I'm going to show you what what these colors indicate. So let me show you that in just a minute. And I'm going to show you some other ones that we may be able to try. So the bleach is actually our most basic chemical. The lightest color we're going to get is yellow. Then it moves on to green, blue, pink, red. Remember that our cabbage, if I were to just add water to it, would just be a lighter blue, yes? Because the water would dilute it. So that means that the cabbage is very much in the middle, right? And I can compare by adding chemicals to it to test its acidity. So if I start off with our blue, which is in the middle of our pH levels, one of our most basic would be bleach, and then moving on all the way to lemon. So does everybody, I'm just going to pour a little bit more of this into here so you can kind of, if it lets me, so you can kind of see all of the different colors. Okay, we've got some very pretty colors here. We've got, okay, so we've got, excuse me, we have from most basic to most acidic. Now, could you test other chemicals using this as your indicator? Knowing this is more in the center, right? Anything that falls from yellow to blue, and that's obviously going to be anything in that green area, green to blue-green, and then moving up until our red. So you're going to have obviously more blue, then pinkish, then purple. No, not sorry, blue or purple in this range, moving on to pink, all the way to red. That is how we find our pH level. So this pH level is a 0 or a 7 if you had to label it. I'm sorry, a 0 or a 14. We go up to 14. This is about a 7. What's this? 0 or 14. What did I say? The lower the number, what does that tell us about the pH level? Julian? The more acidic. So what would this bleach be? Okay, Sinjin says 6.
No, it's 14. But
Oh,
I can't really do
14.
that with my fingers, so.
Okay. Anyone else have a guess? Shh. I'm gonna wait. So acids have the low pH. Yes? So this is a 0, 1, 2, 3, 4, 5, 6, 7-ish, 8, 9, 10, 11, 12, 13, 14-ish, right? The higher the number, the lower the pH. It's more of a base. I brought some other chemicals here to see if we can test them. Maybe I can have some more volunteers. So let's set up another, gosh. Oh, I thought you were doing this for the love of science. All right, let's see where we're going to put this. Let's see where we're going to put this. Ladies and gentlemen, let's see where we're going to put this once we mix another chemical. So the next chemical I thought might be fun to test. All right, so let's say again, who thinks the sanitizer is going to be closer to 14?
Me.
I want everyone voting this time. Who thinks it's going to be closer to 0? All right, Donovan, let me get my camera ready. Let's. All right, ready? Is it working? Do we need more?
No, I just need
hold on.
Mateo made it smell better. It smelled better. I always make it smell better.
All right. So we've added some. I'm gonna see if I can mix it a little bit. Hold on. Hold on.
I mean, I could just open this. Wait, no, I mean, no.
All right, I can't wait anymore, so I'm gonna start.
It's liquid is what. This is the liquid version.
Oh,
I can just use this. What have you done?
it became non-Newtonian. I can't push the fork. That's interesting. So where is it closer to? Oh wait, liquid. Okay. Smells like bug spray. All right. So what do we observe?
I'll make it smell even better.
All right, I've mixed it. What do I observe? What do we know about the pH? What can we tell about the pH? What can we tell about the pH? Is it closer to being a base or closer to being? So where would it go? Where would it go? Closer to an acid or closer to a base? Between the blue and the red, so it's closer to being a base. All right, we can try one more. And now I want to try vinegar. Vinegar. Let's take a vote. Who thinks closer to an acid? Who thinks closer to a base? Who thinks closer to an acid? Hands up. All right, who thinks closer to a base? All right, are we ready? Who would like to come? All right, Matthias. All right. Yep. Ready, guys? What is it closer to? What is it closer to? All right. Fifth graders. I'll wait. Fifth graders, I'll wait. I'll wait. All right. So this is pretty fun. Who thinks acid? Who thinks closer to a base? All right. Ready, Zoe?
Yeah, it's like this.
What do we think? Thank you so much. What do we think? Closer to an acid. Definitely. All right, so here are some other items you can explore with from home. And you can see the full spectrum here of your bases, which is your bleach, all the way to your acids, which is lemon juice. Now, these are some things that you might have at home, right? This one is fun because it's pretty easy. You can just make a sugar solution. I was not expecting that for sanitizer, to be honest, but I guess it depends on how strong. Maybe not a gel sanitizer because that's more water-based, right? all mixed with cabbage juice. So as you can see the water? It just makes it a lighter blue, but it doesn't change the color. So when you have like a blue or an indigo, that's kind of your midway point. It has the most balance. Yes? Yes? It has a balanced pH. As we move more towards yellow, that's where your pH gets lower or higher? Higher. And it means that you have more of a base. Yes? As our pH decreases, we get more acidic. Correct. So if you'd like to try these, some of these are safer than others. I think I did the most dangerous one, which was bleach, but everything else here is pretty safe to use, right? Lemon juice, vinegar, Sprite, water, sugar solution, sanitizer, baking powder. These are all safe to use at home. If you'd like to try this and send me pictures, I will accept it for science extra credit. And if you'd like to submit your unicorn noodles and make those for dinner, feel free. I did want to bring, and maybe you could bring it up here so we could show it and I'll shine the light. Danielle tried her own experiment. Come up here, Danielle. Well, I'm going to show it on the camera first and I'll shine a light. But Danielle did not have red cabbage and she used cherries, right? Okay, so here we go. She used cherries and she was worried it wasn't going to work the same way. But she started off with kind of a pale purplish color. And the part she put lemon on, what do you notice? It became more pink. So what could you tell about the cherry juice then that she used on her noodles? What could you tell based on her experiment? One person. What could you tell about her experiment based on the cherry juice? What could you say? She tested it with cherries. She used cherries instead of red cabbage. What could you tell about the cherries? Yes.
It's more of like a base.
Is it a base? Is it an acid? Yep.
I think that it's more of, okay, wait, so I think it's, okay, wait. So if bleach made it like lighter and yellower, and bleach is an acid, right?
Right.
Then I think it's a base.
Okay,
Because the colors
interesting.
are more pink and those are closer to the bases, like with the what is it called, lemon juice and like hand sanitizer or no hydrogen peroxide.
Interesting.
But
It's not an acid. It falls between an acid and a base.
oh,
Just like the cabbage. Notice that when we added the lemon, it turned pink. It wasn't quite yellow. It wasn't quite pink. It was right in the center, right? So she was able to pour the lemon juice on it and use it as an indicator, which means that cherries must have a very similar chemical to what's found in red cabbage and can be used as an indicator. Not as strong. She got kind of a pale purplish color, but if you get that purplish blue, you're right in the center. So anything you add to it is either going to be more acidic or less acidic. So if you ever want to use something that's an indicator, it should have that kind of a color. Not all chemicals will work. You can't just say, look, I dyed this water blue using food coloring. Well, you can't guarantee that's going to work. It has to have this specific chemical that reacts. All right, how many of you are going to try this at home? Yay! That makes me happy.